Okay, so let's talk about factoring something a little bit different today. And as you can notice, this polynomial is a fourth degree polynomial, and it's a fourth degree trinomial. And so it looks very, very similar to things we factored before. So let's kind of look what we factored before and kind of compare and contrast. So we've been able to factor something that looks like this. Because we could go, oh, well, how do I get x squared? I would do x times x. And then we thought, okay, what would multiply together to give us 12 and add together to give us negative 8? And that would have been negative 6 and negative 2. We would have been able to factor it. Let's look how this is different. The only thing that's different is this, instead of being 2, and this, instead of being 1, is now double. Well, we can still make x times x become like x times x will always be x squared. But we could think, what times what would give me x to the fourth? Well, if we just did x squared times x squared, whoops, that would now, we add these two things together, give me x to the fourth. And even when we think about foiling it, that x squared will become my middle term, which is really, really good. And then the back numbers, like what's going to multiply together to give me 12, but add together to give me 8, that stays the same. So this is going to literally be the same as what we've done before, except this time, instead of these just being regular x's, are now x squareds. Let's have you guys. Okay, so we're going to try to factor this. The first question is, what should go here and here? Hopefully you go x squared, because again, we need these two things to multiply together to give us this. And then you should go, okay, what's going to multiply together to give me 6, but add together to give me 5? And hopefully you go, okay, 3 and 2 should work. So 3 times 2 will multiply together to give me 6, and 3 plus 2 will become 5. So this would be the factored version that we want. Okay. Let's see a couple more examples of these types of things. Okay, so we have this example, x to the fourth minus 9x plus 20. And hopefully, when you think about what will make this factor, we should get x squared minus 4 and x squared plus 5. Now this time, instead of moving on and going, okay, we finished this, and whoops, not plus 5, whoops, minus 5. Because I need them to multiply. That's my bad. So you should go, okay, we got x squared minus 4 and x squared minus 5. But this time, instead of moving on, you should recognize something from the past. And this, you should recognize as a difference of squared. So that's a squared. That's a 4. So you could go, okay, this could be factored further, because x minus 2 and x plus 2, well, negative 2 times 2 would give you negative 4, and negative 2 plus 2 will give you 0. So we could factor this one further. If we tried the same trick with this thing over here, it's just not going to work, because there's no two numbers that will multiply together to give me negative 5, but add together to give me 0. So this thing is just going to stay the same. Okay. So again, you want to make sure that nothing after you simplify will factor. And if you look back here, well, there's nothing that would, in this case, on our last example, that would have added together to give us 3, or multiplied together to give us 3, but add together to give me 0. Nothing here would multiply together to give me 2, but add together to give me 0. So sometimes they will factor a little bit further. So let's go into our next example. Okay, here's my next example, and this may look weird because it's not a trinomial, So you might feel, oh, there's not much we can do with this. But we should always look to see if we can pull anything out. So if we can factor anything out of this. So in this one, I should notice that this is divisible by 2 and this is divisible by 2. So I can grab a 2 out. I should also notice that this has an x and this is an x. So I should be able to pull an x out. And in here, I would be left with 2x to the second minus 5. Then I'll look inside of here and see if this thing factors anymore. Well, when I look inside of here, nothing would multiply together to give me -5, but add together to give me 0. So we are done. That's it. Okay, so let's try this thing now. Again, it should look like the old trinomials that we worked with in the past, except we have a 4 and a 2, which now we should know that doesn't make much of a difference. The only thing that should be a little bit scary about this thing is that it has a number in front of our first term. So anytime you have a number in front of your first term, and if you look across, we can't divide everything by 2. What we want to do is we want to take that first number and times it by our last number and see what we get, which would be -12. Then we want to think about what will multiply together to give me -12, but add together to give me -1. That should be -4 plus 3. We're going to take this middle term and replace it, so I'll have 2x to the 4th minus 4x squared plus 3x squared minus 6. Again, we're going to split it down the middle. After splitting it down the middle, we can factor, this time we can factor out more than we did before. We can factor out more than just an x because both these things share an x squared. So they share a 2 and an x squared. So I'll get x squared minus 2. And here, these things share a 3. So I'll have 3 and x squared. Now let's pool together what we should have. This is what is left over, so it gets pulled together. And this is what they have in common, so it gets pulled together. And again, we want to stop and look and see if we can factor any of these things further. Well, there's nothing that I can multiply together to give me 3, but add together to give me 0. And there's nothing that you can multiply together to give you 2, but add together to give you 0. So these things are factored all the way. So again, your final step should always be to check if these things factor further, because they can. Let's do one more example. Okay. So this thing kind of looks like all our other ones, except this time we have a 6 and we have a 3. So again, I want to think about what x I need to put together to get to 6, and it's 3, because x to the third times x to the third will give me x to the 6th. And then it's the same for our back numbers, where we're trying to get this thing to be -3. So, but I need to add together to give me 2. So -3 or +3 times a -1 would give me -3, and then 3 plus -1 would give me +2. So this would be my answer. Now the question is, does this thing factor further? And today we don't really know. So on your homework and on your answer key, I pulled this from problem 21 right here. And you can see that it looks like they did something else here. And they did. They factored this side further. And this is what we're going to call a difference of cubes. We're going to learn how to factor these differences of cubes tomorrow. Okay? So just for today, this is an acceptable answer. So just leave it like this, because I just want you to kind of get the basics of this thing. Which the basics of this is everything's going to factor like they did before, except sometimes they're going to factor a bit further. Okay? So just try the different problems today.